Lecture 32, Maxima and Minima of a function for two variable, part 2. Now discuss the extremum of a two variable function. So a function fxy is said to have a maximum value at x equal to a, y equal to b if there exists a small neighborhood of ab such that fab is greater than f a plus h and b plus k. Here a plus h and b plus k is a neighborhood point of ab. So as you see in the in that figure, that is a surface. The surface is what? Is a function of xy. Suppose this is x and we can say this is y, and that point is a and this is b. And if the value at ab, that point on the surface xy, so corresponding to that point, the value of the function on that given surface fxy, this is the surface fxy, is what? F A B. Now this FAB, if we take some neighborhood point, suppose if we take the neighborhood point of A here and B here or here, so we can say if suppose this is A plus H at that point, this is a neighborhood point. So and this is say B plus H, sorry, B plus K. So the neighborhood point is somewhere, and corresponding to that point the value of the function is what? F a plus h b plus k. So if the value of f a b means the value of the function at a b is greater than the all the neighborhood point around the that particular point a b, and corresponding values are lesser than the function value f a b, so we can say at that point the value is maximum. Similarly, if we or we can say if the condition f a plus h and b plus k minus fb is less than 0, then we can say at that point function is maximum. And similar for the minimum value, you say the function is said to be minimum value if f a b is less than the neighborhood point of f, the value of the function at neighborhood point f a plus h and b plus k, or we can say f a plus h and b plus k minus fab is greater than 0. So we can say the function is minimum at that point ab. And you can see the another graph of the surface with the surface like this. So that is the minimum value we obtain at ab. So this is a maximum minimum. Now you have to remember what the maximum and the minimum value of the function on AB are called extreme or extremum value, and that point, this point AB, is called stationary point. And if this is a stationary point, so you have to remember the partial derivative of a function at AB with respect to x and partial derivative of a function with respect to y at AB is equal to 0. So we obtain a stationary point. Means if you have a given a function, so you can easily obtain that point, a stationary point. You just differentiate partial derivative with respect to x and put it equal to 0, and similarly partial derivative of that function with respect to y and put it equal to 0, and simultaneously solve that equation. We obtain a point, and that point is what? A stationary point. In the one variable, we say similarly as in one variable, the critical point. Now how to find the stationary point and the extremum value for the function which having more than one variable. So step 1, the given function, you find the following derivatives, that is the partial derivative of a function with respect to x, with respect to y, 2 time partial derivative of a function with respect to x, with respect to y, and with respect to x and y both. Then find the stationary point. As you remember, to find the stationary point, we substitute the partial derivative, that is equal to 0 with respect to x, and the partial derivative of a function with respect to y equal to 0, and solve this equation simultaneously you obtain the value of x and y, which is the stationary point, that is AB. Now after find the stationary point, the step third, you just find out the partial derivative, 2 time partial derivative with respect to x considered as a r, this is r, and 2 time partial derivative with respect to y considered as a t, and the partial derivative with respect to both x and y you consider as a s. Now evaluate the value of r, t and s for the stationary point AB. Means you just differentiate and put the value of x and y is AB, stationary point, put in these, we get r, t and s. Now then evaluate rt minus s square. Now when you get the value of rt minus s square, so there are three cases arise. The first one, it may be the less than 0, rt minus s square is less than 0. If we get that case, so we can say function has no extremum value, means it is neither maximum or minimum. And if rt minus s square becomes 0, so further investigation is required, means this is a case of doubtfulness, so we cannot say the function is maximum or minimum. And if rt minus s square is greater than 0, so we can say function has extremum value, means it is maximum or minimum, means function attained or contain the maximum value or minimum value. Now there are two cases. If rt minus s square is greater than 0, so we can say the function extreme value, now it's maximum minima. So for that we check the value of r. If r is greater than 0, then we can say function has minimum value at the given stationary point. And if r is less than 0, so we can say function has the maximum value at that stationary point. So discuss the extremum value of the function fxy, x square plus y square plus 6x plus 12. So for that, first we find the stationary point for that function. So we find the partial derivative fx, that is the partial differentiation with respect to x, that is 2x plus 6. Now take the partial derivative with respect to y of that function, so we get 2y. Now substitute equal to 0 and solve simultaneously, so we get what this equation implies, x is equal to minus 3, and this equation implies y is equal to 0. So here we get the stationary points is minus 3 and 0. Now we check the function is maxima minima, so for that we use the partial derivative, 2 time partial derivative with respect to x, that is we can also write fxx, which is 2 partial derivative 2 time with respect to y, that is fyy, that is 2, and the partial derivative with respect to x and y is what we get 0. Okay, now this is what this is, we say r, and this is we say t, and this is we say s. Now evaluate r t minus s square, so what we get 2 into 2 minus 0, we obtain 4. Now we check the condition, so r t minus s square is greater than 0. Now we can say at that stage we can say function fxy has extremum value, either it is maximum or minimum. Now because the function attained the extremum value, so now we check the value of r is what? R is 2, which is greater than 0. So if r is greater than 0, then we say f x y is minimum value at the stationary points, and the value of the function is what? So we check f minus 3 and 0, put in that function, so we get 9 minus 18 plus 12, so it is 3. So 3 is the maximum value of the function. So the minimum value of function xy is 3 at the point minus 3 and 0. Here you see the stationary point, when we evaluate the rt minus s square, so we get a constant value. We cannot get x and y in the term of x and y, but we can say the minimum value of the function is what? Is 3 and is obtained at the stationary point minus 3 and 0. Means if we see, if suppose there is a point somewhere, if there is a point minus 3 minus 3 0, so if there is a function, so at that function, this is the minimum value of the function we obtained. So the stationary point is just say where the function has the extremum value. Now discuss the extremum value of the function fxy is equal to x cube plus y cube minus 63x plus y plus 12xy. Now to discuss the extremum value, means the maximum minimum value, first step we just find the partial derivatives. So first we find the partial derivative of that function with respect to x, and what is that? Is 3x square minus 63 plus 12y. Similarly, we find the partial derivative with respect to y, 3y square minus 63 plus 12, get x. Now the partial derivative with respect to 2 time, that is, this is called, we can say, r. So we get 6x, and that is t is what? F. 2 time partial derivative with respect to y, we get 6y, and the partial derivative with respect to x and y both, we get 12. Now this is what? This is, so we say s. Now to find the stationary point, we substitute these point to find the stationary points. So for that we substitute fx, that is equal to 0, this value, and fy is equal to 0. The partial derivative, these partial derivative, put it equal to 0. So we get to equation 3x square minus 63 plus 12y is equal to 0. 3y square minus 63 plus 12x is equal to 0. When we solve this equation simultaneously, so we get says this is equation 1, this is equation 2. So when we solve these equations simultaneously, we get a relation, solve 1 and 2. So we get x square minus y square minus 4x minus y is equal to 0. We just substitute the value of this minus this, so we get this equation, or that equation is also written as x minus y, x plus y minus 4. We just apply the formula a square minus b square and take x minus y as a common. Now here we get two relations, x minus y is equal to 0 and x plus y minus 4 is equal to 0. Now first we put x equal to y in equation 1, in that equation. So you get x square, if we take 3 as a common, so we get 3x square minus 63 plus 12x is equal to 0, or on simplify we get x square plus 4x minus 21 is equal to 0. And when we find the root of that equation, so we get x is equal to minus 7 and 3. And when we put x equal to minus 7 in equation 2, put in equation 2, so we get y is equal to minus 7 and 3. So here by this relation we get a two stationary points. So two stationary points are what we can say, minus 7, 3, 3. Similarly if we use that equation, that second equation, so we put x plus y is equal to 4 in equation 2, so or in equation 1 or 2, so we get, sorry, 1 or 2, any one equation you can use. So we get again a relation x square plus, sorry, we get a minus sign here. I'm writing directly after simplify this, minus 4x minus 5 is equal to 0, and on solving that we get x is equal to minus 1 and 5, and put in equation 2, so we get y is equal to minus 1 and 5. So here the stationary, again we get our two stationary points, again we get two stationary points, that is minus 1, 5 and 5. So now we have total, we have 4 stationary points here, that is minus 7, 7, 3, 3, minus 1, and 5, 5. Now at these stationary point we check the value of the function is extremum or not. Now check the extremity, the function is extremum or not. So for that we check at the stationary point. First we take minus 7 and minus 7. So for that first we have to evaluate r t minus s square. So as you remember, r t minus s square, r is what, 6x and 6y minus 12 whole square. So here we get 36xy minus 144. Now put minus 7 and minus 7 here, so we get 36 into 7 into 7 minus 144. So here you observe the value is greater than 0, so we can say the RT minus s square is greater than 0. So if RT minus s square is greater than 0, so we can say function has extremum value at that point, that is stationary point minus 7 and 7. Now the value is minimum maximum. For that we check r, and r is 6x, that is 6 into minus 7, we get minus 47, which is less than 0. So r is less than 0, rt minus s square is greater than 0, and r is less than 0, so we can say the function fxy is maximum value at point -7, -7, and the maximum value of the function at -7, is what? You just substitute in the function or we get 7, 8, 4. And the similar way you can find the value for 3, 3, -1, 1 and 5, 5. So you can check yourself whether the function at this point is maximum or minimum in the similar way. You just evaluate the rt minus s square and check r is less than or greater than.